The electromagnetic spectrum. In this lesson, you will explore the different regions of electromagnetic spectrum. The different learning tasks set here will lead you to compare the relative wavelengths of different forms of electromagnetic waves. So let's start. First is electricity. Electricity is a form of energy resulting from the existence of charged particles such as electrons or protons rather, either statically as an accumulation of charge or dynamically as a current. And we also have magnetism, wherein it is the force exerted by magnets when they attract or repel each other. Magnetism is caused by the motion of electric charges. Every substance is made up of tiny units called atoms. Each atom has electrons, particles that carry electric charges. Electricity and magnetism in physics, these are the two words often go together, like for example, the horse and its carriage. What is this electricity? In Tagalog, we have elektrisidad o dagitab. Ito ay isang pangkat ng mga pisikal na pangyayari na nauugnay sa presensya at daloy ng karga ng kuryente. Ang elektrisidad ay nagbibigay ng iba't ibang uri ng kilalang epekto tulad ng kidlat, statikong elektrisidad, induksyong magnetiko at kuryente. Ang magnetismo naman ay isang puwersa ng atraksyon o pagtataboy ng mga bagay sa isa't isa na dahil sa paggalaw ng kanya-kanyang mga kargang electric. We're going also to discuss about the brief history of electromagnetic theory. When we say history, there are persons involved in studying this. Let us know who are the persons involved in studying this electromagnetic theory. Without them, we do not know this electromagnetic theory. First, we have Hans Christian Ørsted, a Danish physicist, wherein he discovered that a magnetic needle aligns itself perpendicularly to a current carrying wire, definite experimental evidence of the relationship between electricity and magnetism. So, yung paggalaw ng needle. Usually, yung needle na yun makikita natin sa compass. Bakit to gumagalaw yung compass? Yan. And there he is. Next, we have Andre Marie Ampere. He is generally credited as one of the first to discover electromagnetism. In the early 1820s, after learning about the electromagnetism experiment of Hans Christian Ørsted, Ampere began to formulate a combined theory of electricity and magnetism, doing several demonstrations involving magnetic and electrical forces. So, he followed Hans Christian Ørsted. Based sa study ni Ørsted, he followed it, but he made his own experiment. So there he is, and it is his experiment. So we have here the battery. As you notice, we have the attraction and repulsion. Usually we hear this on a magnet. So we have the electric current, then we also have the battery. Next, we have Michael Faraday. It is the electromagnetism in 1821. He took the work of Ørsted and Ampere. So meaning to say the ideas of Ørsted and Ampere, but on a magnetic properties of electrical currents as a starting point. And in 1831, after 10 years, he achieved an electrical current from a changing magnetic field wherein it is a phenomenon known as electromagnetic induction. So there, there it is. As you notice, we have the switch, we also have the battery, and a wire, a layers of copper coil interwound with cotton and calico, and also a galvanometer. Next, we have Joseph Henry. He was an American scientist and engineer. While building electromagnets, he discovered the electromagnetic phenomenon of self-induction. So, as you noticed on the picture, the Joseph Henry electromagnet, it is wrapped up insulated wire. So, as you notice, we have the north and the south wherein we found this on a magnet. Next, we have James Clerk Maxwell. The electromagnetism in 1821 also. He took the work of Oersted and Ampere on the magnetic properties of electrical currents as a starting point, and in 1831 achieved an electrical current from a changing magnetic field, a phenomenon known as electromagnetic induction. According to Maxwell, there are two basic principles of electromagnetism. First, we have changing electric field in space produces a magnetic field. And second, changing magnetic field in space produces electric field and vice versa. That is according to Maxwell. So there he is. And as you notice, the electromagnetic wave, we have the magnetic field, and we have the electric field on the lower part, magnetic field on the upper part, and the direction of propagation. And we also have the wavelength or the measurement of each wave. And lastly, we have Heinrich Hertz. He was a brilliant German physicist and experimentalist who demonstrated that the electromagnetic waves predicted by James Clerk Maxwell actually exist. So, according to him, the work of Maxwell is actually exists. Hertz is also the man whose peers honored by attaching his name to the unit of frequency. A cycle per second is 1 hertz. Of course, also with Andre Marie Ampere in current, we have ampere. The unit is ampere. So, as you notice in the picture, we have the electromagnetic waves. So, we have the receiver, we have the capacitor. On the box or inside the box, we have the spark gate, the coil, we have the battery, the switch, and also the transmitter. Next, we have the electromagnetic spectrum, wherein our topic for week 1 and week 2. Electromagnetic spectrum, it is the electromagnetic spectrum is the range of frequencies of electromagnetic radiation and their respective wavelength and photon. It is the spectrum or the continuum of electromagnetic waves arranged according to frequency and wavelength. It is the gradual progression from the waves of lowest frequencies to the waves of highest frequencies. So what are those wavelengths and frequencies? So we have here the electromagnetic spectrum also. As you notice, we have the prism. When the white light enters the prism, it deflect to different colors. So the electromagnetic spectrum is the more familiar to you than you might think. The microwave you use to heat your food and the cell phones you use are part of this electromagnetic spectrum. The light that our eyes can see is also part of electromagnetic spectrum. This visible part of electromagnetic spectrum consists of the colors that we see in a rainbow, from red, oranges, through blues and purples. Each of these colors actually corresponds to a different wavelength of light. So those are the waves. Look at the waves. Observe what have you noticed on the waves. Each color in a rainbow corresponds to different wavelength of electromagnetic spectrum. According to its increasing frequencies, we have radio waves, microwaves, followed by infrared, visible light, ultraviolet, X-rays, and gamma rays. So the regions of electromagnetic spectrum. So look at that. We have it is in decreasing form. So from gamma ray to radio wave. So in gamma ray, we have this atomic nuclei, X-ray, atoms, ultraviolet molecules, visible or visible light protozoans, infrared needlepoint, microwave, the butterflies, and humans, and of course the radio waves more on buildings. So, as you noticed on the frequency per hertz, we have the temperature of objects at which this radiation is the peak wavelength emitted. So, penetrates Earth's atmosphere? The answer is yes or no. So, as you notice, we have on that part the gamma ray, X-ray, ultraviolet. That is no, no, no. The visible, of course, yes. Then a part of infrared, then microwave, no. And a part of radio wave is yes. Next, radio and TV waves. This is the longest wavelength, lowest in frequencies. They can be produced by making electricity, oscillates in an aerial or a part of antenna, wherein antenna used to transmit sound and picture information over long distances. So that is the example, the antenna. Is that an antenna? Satellite. Yes. Followed by microwaves. What is this microwaves? Microwaves is a very short wavelength, can penetrate obstacles that interfere with radio waves such as clouds, smoke, and rain. Microwaves carry radar, landline, phone calls, and computer data transmissions as well as cook your dinner. Example of that is microwave. Um, on microwaves, we also have the radar, terrestrial communication is also part of microwave wherein used to transmit television news coverage from mobile broadcast vehicles back to the station. Of course, on the picture, the microwave oven. Next, infrared. Infrared is a wavelength is too long to be visible to the naked eye, can penetrate obstacles that interfere with radio waves such as clouds, smoke, and rain. Microwaves can carry radar, landline phone calls, and computer data transmissions as well as cook your not on that part because that is part of microwave. Infrared radiations lies beyond the red end of the visible light and it is emitted by all objects. So the following are useful applications of infrared radiation. So we have in photographs, we have the scanners, remote controls that are used in televisions, night vision goggles, and some autofocus cameras have this infrared. Yun. Next, we have the visible waves or visible lights wherein it is shortest in wavelength that can be present and also can be detected by the eye. So example of this is the light waves or the light carries by sun. Objects that are perceived as different colors based on which wavelengths of light an object absorbs and which it reflects. Next, example of yes, the light from the sun. So we have the wavelength of different colors of light. We have red, the wavelength. I'm going to tell the color. First the color followed by its wavelength. So we have red 622 to 700 nanometer, orange 597 to 622 nanometer, yellow 577 to 597 nanometer, green 492 to 577 nanometer, blue 455 to 492 nanometer, and violet to indigo 390 to 455 nanometer. Next, we have the ultraviolet waves wherein it is shorter in wavelength than violet light and carry more energy, have even shorter wavelengths than visible light. Ultraviolet waves are the cause of sunburn and can cause cancer in living organisms. High temperature processes or emit ultraviolet rays. This can be detected throughout the universe from every star in the sky. So, yan. On the part of ultraviolet radiation or ultraviolet waves, of course, the sun is our main source of ultraviolet radiation, but there are also artificial sources of this UV. Ultraviolet radiation like UV lamps that are used in banks to check the signature on a passbook. It is also used in sterilizing water from drinking fountains. Some washing powder also contains fluorescent chemicals which glow in sunlight. This makes your shirt look whiter than white in daylight. Ultraviolet radiation in sunlight produces also vitamin D in the skin and gives us tanning effect. But since these UV rays have high energy, it could be harmful to some extent. So, as what I've said a while ago, it can cause sunburn and also can cause cancer or skin cancer in living organism. Next, X-rays. X-rays short in wavelength, high in frequency. X-rays also are extremely high energy waves with wavelengths between 0.03 and 3 nanometers, not much longer than an atom. So as you noticed, we have the doctor and he checked the X-ray. For sure, you are all familiar with that X-ray film. And lastly, we have the gamma rays wherein Gamma rays are the highest frequency in electromagnetic waves and are emitted by only the most energetic cosmic objects such pulsars, neutron stars, supernova, and black holes. Gamma rays also lie at the other end of the electromagnetic spectrum, and of course, shortest in wavelength and high in frequency. They carry the highest amount of energy. Thus, they are more dangerous. Gamma rays are very strong that they can kill living cells. Gamma rays are used, these gamma rays are used to treat cancer through the process called radiotherapy. They are also used for sterilization for drinking water and used also in the hospital. So I think that is MRI. Also in chemotherapy. And that's all for the week 1 and week 2 for our Science 10. Thank you for listening and reading my slides.